Okay, so I'm hoping that you all remember what the picture for tangent looks like. So let me give you my best artist's impression of what tangent looks like so we can talk about untangenting. What are these? Asymptotes. Where do they happen? Yeah, 90 and minus 90. I'm going to draw this in radians, but you can draw it in degrees if you want. So I'm going to say this is minus pi over 2 and pi over 2. But same picture in degrees, different labels on the x-axis. And then, what's the picture in the middle look like? What's the tangent between these? It's like minus infinity through 0 and then up to positive infinity? Yeah. So it's this kind of funky, like almost cubic looking thing. But what's the weirdness?
It doesn't
Yeah, it does it over and over. If I go over here, right, where's this next asymptote happen? Nice try, guys.
No. Yeah.
Yeah, that happens at 3 pi over 2. Why does it happen at 3 pi over 2 and not pi? Yeah, because at pi, right, I know what the tangent is, it's 0. So I get another one of these whoopties, right, with a center at pi.
That just keeps going.
And then there's another whoopty on this side. And another one over here. Right, and it's frickin' whoopties all the way down, right? Both sides, lots of whoopties. It does pass the vertical line test. Right? This thing is a function. Its domain doesn't include all the values, right? Because specifically at the kind of 90 minus 90 style things, I don't know what the heck to do with it. Right? So the domain isn't everything. But it's still a function, right? For everything that's in the domain, at least it passes the vertical line test. You guys see that? That's like me just tracing with a ruler. And yeah, these are really steep, but they never actually get to vertical. That's cool with us? So it passes the vertical line test, which means it's a function. What doesn't it pass? Crap. That's going to be a problem, right? So my whole idea was to take trig functions, right, and un them, right? So I wanted to talk about untangent. But a horizontal line through here hits lots of times, right? Like, here's my horizontal line. Boom. Problem. 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 How many of these do I need to have before I don't have a problem anymore? I'm only allowed one horizontal intersection, right? Okay, so what's the obvious thing to do? Get out your frickin' eraser, right? Eraser, and what? What am I going to dump?
3 of them.
Yeah, so I'm going to dump all the whoopties over here. Okay, so no more problem over there. Which one do you want to keep?
The one at 0.
Yeah, good. The one in the convenient angles, right? So I'm going to keep the one that's got 0 in it. I'm going to ditch this. Okay, so there's my tangent. Do you guys remember how inverse functions work? Yeah, they flip over the line y equals x. So if I flip this over the line y equals x, I get my inverse function, which looks like what? I should have brought my piece of plexiglass. That would have been... What am I drawing here? Yeah, the asymptotes, right? They're going to flip too. You guys see that? So how high is this one going to be? Where's this?
Pi over 2.
It's going to be pi over 2 high, right? This is going to be minus pi over 2. And your picture is going to look like that same whoopty, right?
Just that.
Just the other way. You need to cock your head at it, flip it over. So this thing here is going to be what I call tangent inverse. You guys all good with that? Cool?
Yeah.
Okay, this is the most convenient one. The other ones are less convenient.
Wait, so it's twisted and turned on the side?
Yeah, so I had to take the whole picture, and flip it over y equals x.
How is that one movement? Because like you're doing two, so you're like twisting it and then rotating it that way.
Yeah, so you can do it as two. You can flip and then flip. But it's one twist around y equals x.
Just draw a z axis.
Okay. I see. That makes sense.
Yeah, that's a rotate around this thing. You guys see that? I'm exchanging the x and the y axis. Right? I'm swapping the inputs and the outputs because that's what an inverse function does, right? It makes the outputs into the new inputs. So flip across that output input switch. All right, so here's my graph for tangent inverse, the orange thing. Question for you. What are the domains and ranges for tangent inverse? So I'm talking about tangent inverse, right, as a function. What's it going to do? What are its inputs going to be?
Inputs are going to be everything now.
Yeah, good. It's going to swap the domains and ranges. Well, it totally would, except I modified it, right? You guys see that? Like the thing I flipped wasn't tangent, it was part of tangent. So I have to be a little careful. So what kind of objects does tangent inverse take?
No.
So tangent outputs takes an angle and outputs a ratio, right? So tangent inverse is going to do, it's going to take a ratio. So I'm going to take a ratio of an opposite side over an adjacent side, right? Really a number here. And I'm going to turn that into what?
An angle.
Yeah, that's going to turn it into an angle. You guys see that? Okay. What kind of ratios can it take? If I look here, you guys see that? So I'm asking, what's the range of the, or what's the domain of the yellow function
Anything.
for the orange function?
Pi over 2.
I'm asking what x's fit in there, right? So that's a smush this way picture. So if you smush the orange this way, I think you get all the x's.
Then
You guys see that? So this takes, really, tangent inverse takes all of R and turns it into, what angles can it output now?
that's between pi over 2 and negative pi over 2.
Yeah, it has to output angles that are strictly between minus pi over 2 and pi over 2. Right, that's the range when I smush onto the y value. So this takes all of R and turns it into things like minus pi over 2 to pi over 2. Why am I using round brackets and not a square one?
It's infinity. Or no,
Because it
no, it's-
reaches out, but it's
Good, because those were asymptotes,
Yeah.
right? And so the tangent function doesn't know what the heck to do with 90 degrees. So why would the untangent function be able to give you 90 degrees? Does that make sense?
Mhm.
Like, there's no way tangent takes 90. So getting 90 as an output would be really bizarre from an untangent function. You guys see that? Okay, so this is the key for these. Things got a little funky. When I inverse tangent things, I can only get angles between minus 90 and 90. Can I tangent angles that aren't between minus 90 and 90? Yes, I definitely can. So be a little careful with this. This thing's not actually an unfunction, meaning if I do tangent inverse to tangent of something, I don't necessarily get this angle theta back.
So
See
we can
that?
fix that?
Uh-uh.
That's the way it is.
Yeah, this is the way it is. This is not necessarily theta all the time. You guys see this? This is like the theta that's between minus pi over 2 and pi over 2. This does like a, hey, it's not quite the same angle, but it's kind of the idea of the right angle thing. You guys see that? What I mean is, this is a little bit like reference angles and coterminal angles, right? We're used to taking an angle and saying, hey, that angle's not convenient. Here's another one that acts similarly that is convenient, right? That's a little bit like what's happening here. We're going to fiddle with exactly how that works. But for right now, I just want you guys to know that these two things don't quite cancel all the time. Cool? No. Good. Yeah, it's fundamentally kind of wrong feeling.
I'm thinking you're going to show us what happens when it doesn't.
Yeah, I'll show you what happens when it doesn't. For right now, if we do standard angles, right, if the thetas are all between minus 90 and 90, this thing will be fine.
Okay.
Right, it will actually give you the right angle. If it's not between minus 90 and 90, then things get a little fuzzy.
Well, I mean, that's just half the circle. We just pretend like it is.
Yeah, and that's exactly what we're going to do.
Okay.
We're going to use a little context to figure it out. Cool? Questions on this? You guys want to get the other two graphs quick?